In this video, we'll be going over some of the important properties of the definite integral. Okay, so we'll look at these five. I'll go through each of these individually. So the first one, notice that the limits of integration are both a here, so they're both the same value. So anytime we have that, that integral is equal to 0. And if you think about it, I mean, one way to interpret an integral is the area under the curve. Usually we're going to say from A to B, but if we're from A to A, well, there's no area in between. If we say A in both positions, I mean, it's kind of like saying, what's the difference between 5 and 5? Well, there's no difference. The second one, if we notice that we have the limits of integration here. So if we're taking the integral of the same function and we reverse the limits of integration, that will mean one of those integrals will be positive and one of them will be negative. So these integrals are opposites of each other. The third integral property, the third property we have here is if we're taking a sum or a difference inside the integral, so the integrand, we have a sum or difference, then we can split that integral up into two separate integrals as either a sum or a difference. And notice that we keep the same limits of integration. So if it's from a to b in our original integral, we're going to have a to b in each of these. The next property we have, well, if c is a constant here that's getting multiplied by a function, we can factor out that c and multiply it by whatever the integral ends up equaling. And then the last property is if we have some integral between a and b, so this one might help with a picture. So say we have this integral, this is a, and this is b. Okay, so instead of finding, and let's call this f of x, so instead of finding the integral over that entire interval at once, what we could do is if we identify some value c, a value that we would assign c a value that will help us evaluate that integral, but then we could evaluate each of these integrals separately. So then we'd have from a to c, and then we'd have from c to b, and we could add those results together. So we'll look at a quick example here. We're given these three integrals, and then we're going to use these integrals to evaluate some new integrals. So the first one is from the integral from 2 to 7 of 9 times g of x dx. Well, using that constant property we had, we could factor out the 9, and we're left with gx dx. Well, we know that, oops, I forgot to say what this was equal to, what the integral of g of x was equal to. So the integral of g of x is equal to 8 here. So this is ultimately going to be 9 times 8, which is 72 for part A. The next one, we have the integral from 4 to 7 of f of x dx. So I think how we want to look at this is, suppose we have some function and we have 4 to 7. So we're looking at this, but what we're given is we have 2 to 4 up here, and then we have 2 to 7. So if we're given 2 to 4, and we're given 2 to 7, to find from 4 to 7, well, we could subtract 2 to 7 f of x dx minus 2 to 4 f of x dx. And I think that would do it for us. So this first integral from 2 to 7, that's 2, and then minus the other integral. That leaves us with 9 here. Another way of thinking of this is, well, the integral from 2 to 7, we could rewrite that as the integral from 2 to 4 of f of x. That's right, the dx is in there. Plus the integral from 4 to 7 of f of x dx. So this question is saying, well, what is this one equal to? But if we already know the values of these first two. So this is 2, 4 to 2, or 2 to 4 is negative 7. So kind of what is this? This last integral. So that is going to be 9 is equal to what we're looking for. And this is using this last property down here. How we can, if we have if we have an integral over some interval a to b, we could split that up into two separate intervals. And we have one last one. This says find the integral from 2 to 7 of f of x minus 12 g of x dx. And so what we can do is when we have the sum or difference of two functions, we can split these up into two integrals using the same limits of integration. So the limits of integration here are 2 and 7. So we have f of x from 2 to 7, that's equal to 2, minus, I'm going to factor out this 12. Okay, so we're left with 2 minus 12 times, well, the integral of g of x from 2 to 7 is 8. So we have 2 minus 12 times 8 is 96, so negative 94 here. So to interpret that answer, because it's negative, that means there's more area under the x-axis compared to above the x-axis.